Hello guys, welcome to the mathematics lesson. This is the mathematics lesson 13. In today's lesson, we are going to continue with the sum of an arithmetic progression. The sum of an arithmetic progression. Alright, so what is the sum of an arithmetic progression? We are saying that the sum of an arithmetic progression is called the arithmetic series. The sum of an arithmetic progression is called the arithmetic series. So, therefore, an arithmetic series is an arithmetic progression written with a plus sign in between the terms. So if we have an arithmetic progression and then we decide to put a plus sign in between those terms of an arithmetic progression, then we are now coming up with what we call the sum of an arithmetic progression or the arithmetic series. So we are saying, for example, if we have this as our arithmetic progression where we have 1, 4, 7, 10, and 13, and this we are calling it as an arithmetic progression because the difference between the consecutive terms is constant. Then we are saying if we decide to put a plus sign in between these terms of an arithmetic progression, then this one no longer exists as an arithmetic progression, but comes as an arithmetic series. So this one is an arithmetic series, and it is the one we call the sum of an arithmetic progression. So we are saying that the symbol Sn is used to represent an arithmetic series or sum of an arithmetic progression, where n is the number of terms in the series. So this n here simply means the number of terms in the series. For instance, how many terms do we have in this series? 1, 2, 3, 4, 5. So meaning n in this case will be 5. Alright, so let's push this one up here so that we continue. So now what we are saying here is that if we were to find the sum of this arithmetic series here, we would do same S5 because there are how many terms? 5. So in short, this one can be read as the sum of 5 terms of an arithmetic series. So we are saying for the sum of an arithmetic series now, it will be equal to 1 plus 4 plus 7 plus 10 plus 13. And then it will be sum of these 5 terms is, now you add all of them, and this will be 35. So we are saying if you have a very long sequence of arithmetic series, it will take time, or it will take a lot of time to find the arithmetic series of the sequence, and hence a short way has to be derived to help deal with the problem. So you have seen we have been able to find the sum of this arithmetic progression or series because this one is just a short series. Now imagine we have a series with maybe 100 terms, not 5 terms, 100 terms. So how quick can we find that? By doing this manual, adding this plus this plus this plus that. So we are saying it can take a lot of time. So we are saying hence a short way has to be derived to help deal with the problem. So now we are going to look at how we can derive the formula for finding the sum of an arithmetic progression or finding the arithmetic series in a short way. All right, that's what we are now going to derive the formula of finding the sum of an arithmetic progression or arithmetic series. All right, so let's move this up here, and then let's say we have the same one here. So now we are developing the idea. Pay attention. So we are saying 1 plus 4 plus 7 plus 10 plus 13. Then we add it in reverse. So in this side, on this side we say plus S5 equals, on this side we start reversing it from the highest to the lowest. So we start with 13 plus, then 10 plus, and then 7 plus, then 4 plus, then 1. So then we add S5 plus S5, it will give us 2S5 equals, then we start adding corresponding terms. 1 plus 13, which gives us 14, then we'll drop a plus, then 4 plus 10, 14, then plus, then 7 plus 7, 14, then plus 10 plus 4, 14, then plus, then 13 plus 1, which will be 14. So you discover that we find the same terms throughout. Now, the shortest way of finding this is saying a 2s5 is equal to, just counting, since they are all the same terms, and how many are they? They are 5. So it is as good as saying putting 5 here, then times 14. Because if you add 14 plus 14 plus 14 plus 14 plus 14, it is as good as saying 5 times 14. So the number of terms times this just gives you the sum. So we are going to say, all right, so say 2s5 is equal to 5 times 14, which gives us 70. Then now we want to remain with the sum here. So the space is not enough. Let's push here. So 2s5 is equal to 70. Now we want to remain with s. We'll say divided by 2, divided by 2. So these two will cancel, all right? So remain with s5 is equal to 2 into 70, 35. So you have seen that using this way, we have arrived at 35 in the similar way we found it here just by adding. So this will help us to derive the formula. So please pay attention. We added this, and then we reversed, we added the corresponding terms, then we found this. So now this is going to help us find the formula for calculating the sum of an arithmetic progression very quickly, no matter how many terms are there. All right, so let's push this one out, and then let's start afresh. So now we are going to develop the formula, but before we do that, you must understand that this is what we are calling as an arithmetic series. And in an arithmetic series, then there's a common difference between consecutive terms that are being added. For instance, between 1 and 4, the difference which is there is 3. So the difference between consecutive terms is actually constant. So here, if the difference is 3, then from 4 to 7 also the difference is 3. Then from 7 to 10 the difference is 3. Then from 10 to 13 the difference is 3. So we are saying this one is called the common difference, and it is represented by letter D. So now, having understood that in an arithmetic progression or arithmetic series, the terms differ from each other by a common constant known as D, then this one will help us to derive the formula. For instance, if we were to say, let's find the sum of the terms, or let's come up with an arithmetic series where we know that the first term is what? 1, and then the difference between the terms is 3, the common difference. Then for us to be able to come up with the arithmetic series, when we know the first term, is just by getting the first term plus, then we get the first term again plus the common difference. So again we say plus. So when we get 1 plus 3, you'll find that it will give us 4. Then we say, open brackets. So how can we arrive at that? It means the previous one, you add 3 again. So we got this one, we got 1, we added 3. It's the one that can give you 4. Then here, for us to get 7, we actually get this previous one, which is 1 plus 3. Then we add again 3 as a common difference for us to arrive at 7. Then plus, for us to arrive at 10, then we get this previous one, 1 plus 3 plus 3 plus 3. Then we add another 3 for us to arrive at 10. All right. Then plus for us to arrive at 13, we're saying we'll have open brackets. Then first we get the previous term. So the previous term is this. Then to which we are going to add 3 again, the common difference. So you find that this now plus this will give us 4. This now, when you add 1 plus 3, 4 plus 3, 7. Then we put this plus here, then 1 plus 3, 4 plus 3, 7 plus 3, 10. Then plus, then you get this one, 1 plus 3, 4 plus 3, 7 plus 3, 10 plus 3, we'll get 13. So knowing the common difference and then the first term can enable us to come up with an arithmetic series. Now let's say now we don't know the number of terms, because here we are told the number of terms is 5. That's why we have ended at 5. 1, 2, 3, 4, 5. Now let's say we don't know the number of terms, but we know the first term. The first term, remember, when we started this topic, the first term is always represented in an arithmetic progression by A. So if A is the first term, so here now we are driving the formula. That's what you should know. So if A is the first term, for us to be able to arrive at the other term, we get A the first term, then A, the same A the first term, plus then the common difference, D. That will be able to make us find the second term. That's how we can find the second term. Then plus the third term can be found by getting the second term, then to which we add again the common difference. All right, again, the fourth term again can be found by getting the previous term, to which again we add the common difference. All right, so now here you will notice that if we add now, the first term is here, then this one is the second term, then plus, then this one will put open brackets A, then here we can add D plus D, which will give us 2D, then plus, then we'll have A, again plus D plus D plus D, which will give us 3D. So this is how we can come up with an arithmetic, or the sum of an arithmetic progression, or actually the arithmetic series. So here we can still continue adding on, but now we are not adding on, we are about to drive the formula here. So pay much attention. This kind of mathematics is good because it helps your brain to expand. All right, so you say the sum is equal to, now we are saying this one here, it is called the first term, which is T is equal to 1, the first term. Then this one plus this one is called the second term, T is equal to 2, second term. Then plus, then 3, this one is called the third term, T is equal to 3. This one is called the fourth term, T is equal to 4. All right, then plus, now we say dash, dash, dash. We want to continue now. We are tired now, we want to continue to see the other term, the nth term, which is the term that is on the last, that we don't know. The number last term that we don't know can now be represented by T n, because you count 1, 2, 3, 4, 5, 6, 7, just as we did here. We said 5, because how many terms are there? 1, 2, 3, 4, 5. So we put n here. So now, even here we have n, which is the total number of the terms 1, 2, 3, 4, 5. Now, in this case, they are not 5, because when we say plus and dot dot, we are saying there are other terms here that we do not know, but we have really gone to the last term, so that when we count the terms which are there, including these which we have left and the last term, the number comes to n, which is the number of terms. Now, we want to know the formula for finding the number of terms. We know the formula for finding the fourth term, this one, it's this one here. Now, how about the nth term? So let's say we want to find the formula for finding the nth term here. So say dot dot, also open brackets, it will also have a plus, then what now must come here must be derived from the fact that when you check, you will notice that here on after a they are coming d and then another number. So this number has got a relationship with this term here, the number of the term or the position of the term. This is position number 4. 1, 2, 3, 4. So this term is on position number 4. So you notice the number multiplied with d, the common difference, has a relationship with the term or the position of the term. So what is the relationship? We are saying this number is less than by 1 from the position of the term. That's the relationship. So in short, for us to know this number here, we can get this term minus 1 for us to get this. So for you to know what number you multiply with a d, you only subtract 1 from the position of the term in order to know that number. Now even here, since we are at nth, for us to know what we will multiply with the d here, it is just getting nth minus 1. So we'll say open brackets, n minus 1, then times d. So n minus 1, it is the one that we should multiply with d in order to come up with the formula for finding the nth term or the last term. All right, so I hope you have gotten the point. If you haven't gotten it, let me know in the comment section. All right, so now what we are saying here, guys, is that we have now derived the formula for the arithmetic series, how it can be derived from the first term to the nth term. All right, so now what is following next is quite tricky. So let's push this one up here. So what is following is quite tricky. So what we are going to do is to do what we did in the previous one. In the previous one where we had 1, 3, 4, 1, 3, it was 1, 4, 7, 10, 13. When we added those, we got 35. But we said let's do it in a quick and shortest way. Let's find out what can be done. We added those 1 plus 4 plus 7 plus 10 plus 13. Then we reversed them. Then we added. Then we found that whatever answer we found was as good as we found in the first place. So here also we'll do the same. We are going to say here also plus SN, the sum, then equals. Now again we'll start reversing, adding this one from this side going this way. So we'll get this one, which will be open brackets a plus open brackets n minus 1, then multiplied by D. Then plus. Now the tricky part is this. So you are going to think we are picking this here. Not true. So we are going to look at now how can we get this from here. How can we come to this? If we are reducing, coming from here, for instance, we had 1, 4, 7, 10, 13. So there the common difference was what? Was in 3. So if you were to reverse from 13 to 10, it's just you get 13. Then if you are to get from 13 to 10, you remove 3 from 13, then you get 10. Then if you are to get to move from 10 to 7, you remove again 3 from 10, you get to 7. Then if you are to get to 4, you remove 3 from 7, then you get to 4. Then if you are to get to 1, you remove 3 from 4, then you get to 1. So that is how we are going to work with. So you realize that going this way, the number decreases. So here we have 3, here we have 2, here we have 1, here now we have 0. That's why we are having A. So the number which is multiplied with 3 reduces. So here it is 3, here it is 2, here it is 1, here it is 0. That's why we are having 3, because if you say it was 0, that's why we are having A. I mean, it is because 0 times D, it is actually 0. Hence we remained with the A. Yeah, that's how it can remain with A. I mean. So in the similar manner, going this way, this number is reducing. So meaning it is decreasing. So how is it decreasing? 1, 1, 1, 1. So it is as good as when you pick this one, to get to this one, again you pick the same one like this, A, then plus, then you say open brackets, then you say N, then minus C. Instead of it being 1, it should be now 2. So it was 1, it is now 2. The negative now are increasing for you to start going in the reverse direction. So now this one is what you, this one, when you subtract 1, you arrive at this one. Then this one, when you subtract 1, then you arrive at this one here. Now here, when you subtract 1 to this one, you subtract 1, you say plus D, I mean, then you say open brackets plus A plus C, open brackets 1 minus. Again, you subtract 1 from this one in order to arrive at this one. So you have 3 here, D, then plus, then open brackets A plus C, then open brackets again to arrive at this one. Then here again you subtract 1 and say N minus C 1, then in D, then plus, then you arrive at this one exactly at A. So next you add Sn plus Sn, it will be 2Sn equals, then here the trick part is now you start adding. This is the term here which you should add with this term. So on this term, there's no this part which contains D. On this one, there's only A. So you add A and A so that it will be open brackets 2A, then plus this. Since there is no part for this on A, so you write as it is this N minus 1D. Then you say plus, then you shift this term with this term here. Again, this will add with this one, then this D with this one. So if you add this plus this, you say open brackets, it will be this plus this 2D, 2A I mean. Then if you add this plus this, and then you factorize in that addition, you'll see that, or you arrive at open brackets N minus 1 cross brackets plus D, then plus. Again, you shift this plus this. So again, on this one, you add this plus this, which will give you A2 or 2A. Then again, if you get this part plus this part, it will give you this part. All right? Then you say plus, then you get this part. Then this part, you get A plus A, which will give you 2A. Then this part and this part, you see, it will be this. So it will be 2A plus, open brackets, n minus 1, close brackets, d. Then, yeah, that's what you are going to find. So how many are there? 1, 2, 3, 4. Here there are how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So now I just decided to cut them for the reason being that I had no space here. But however, you notice that what is found here is the same as what is found here, is the same as what is found here, is the same as what is found here. So this went with this, this with this one with this one, this one with this one, then this one with this one. So this one with this one gave us 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 this one. This one with this one as well can still give us this, but however I didn't have space here, so it doesn't matter, because even that one can still give us the same. So now we say equals. So now what is following next is this. So since n represents the number of terms here, 1, 2, 3, 4 in short. Now since n represents the number of terms, so it is as good as getting this, only one of these, then multiply by the number of terms. So we get n, which is the number of terms, then get one of these, because they're just the same. So say this, we multiply. Then if we say over 2, so that we remain with the sum of the n's at any terms, then here divided by 2. So these 2 and 2 will cancel, remain with the Sn equals, then we'll have this like that. So this one becomes the formula for finding the sum of the series, the sum of the arithmetic progression whose number is n. So they can be 100, 1000, using this formula very fast to find the sum of those terms, provided we know the first term, we also know the common difference between the term, and then we know the number of those terms in that arithmetic progression or series. All right, so let's push this formula up here, and then we are saying, let's say the last term is known and is represented by L. So we know the last term, and then we represent it by L. So we are saying, let's go back to this, which we drew previously, and they say this is the last term, and then we know it. Then this last term, let's say we represent it by L. All right? So if this last term is represented by L, then this formula of ours is going to change. Take note. So it is going to be like this. Then what we are going to do here is to expand 2a. So 2a simply means a plus a, then plus, then this part here comes in, n minus 1d. So we have just expanded. Now when you check, after expanding this, when you check this part here, it is similar with this part. So here we change as L, so we rewrite it as Sn, then n over 2, then we are going to say brackets, then we write a plus this whole part here represented by L. So this one again becomes another formula. So we have two formula for finding the sum of an arithmetic progression or the arithmetic series. So we have this one and then this one. So this one, when the last term is known, you use this formula. This one, when the last term is not known, you use this formula. This one. All right, so let's look at an example. So this example says 1. Calculate the sum of the integers from 10 to 45. Then 2. The first three terms of an arithmetic progression are 5, 7, and 9, and the sum of each terms is 480. Show that the AP has two terms. Right? So the arithmetic the arithmetic progression has 20 terms. All right, so let's continue with the answering this. So we are going to say solutions 1. So 1 for question 1. So we are told calculate the sum of the integers from 10 to what? To 45. So we know the last term is 45. So meaning we use this formula Sn is equal to n over 2, then open brackets a plus l. Then what is important now, it is to start knowing from 10 to 45. So meaning a is the first term, which is 10. Then L is the last term, which is 45. Then N, which represents the number of terms. So from 10 to 45, how many terms are there? How many terms are there? So meaning you're saying 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, up to 45. How many terms are there? So the simple way is by saying 45 minus 10, you find what? 35. Then since 35, meaning you have subtracted 10 from that number. So now you add 1 because 10 is a single term which we subtracted. Now we add it so that we have the total number of terms from 10 to 45, which will be 36 terms which are there from 10 itself and 45 itself included. So we know now n is 36. Then we are now going to substitute to say n now is 36. So we are finding the sum of 36 terms from 10 to 45. So we're going to say here we have 36 over 2, then open brackets, then the first term here is 10, then plus L, which is 45, the last term. Then we are going to say 36 divided by 2, which will be 18 here. Then here we'll say times this one plus this, which will be 55. All right, then we are going to say the sum of the 36 is equal to 18 times 55, which will be 990. All right, so let's move again to question 2. So question 2, they are saying the first three terms of an arithmetic progression are 5, 7, and 9, and the sum of its terms is 480. So here they are saying the first three terms. When they say the first three terms, they haven't told us that this arithmetic progression has terminated. So the first three terms of an arithmetic are, so they have just given us 3, are 5, 7, and 9, and the sum of its terms is 480. So the three terms and other terms there, when you add their sum, it is what? 480. Then the question says, show that the arithmetic progression has 20 terms. Now they need us to show that this one has 20 terms. All right, so now since we do not know the last term, so we are going to use this formula. Sn is equal to n over 2, then open brackets 2a plus open brackets n minus 1, then close bracket d. Where we are going to say now, a actually is the first term, the first 3. So if they are saying the first 3, then the first term is 5. Then the next thing is to find n, the number of terms. So they have told us the sum of its terms is 480. Show that the AP has 20 terms. So it has how many terms? 20. So n is equal to 20. Then next is d. D is the common difference between terms. So between these two terms, consecutive terms, let's say 7 minus 5, what do we get? 2. So now for us to show that this one will give us this, it is to get this information, put it in this formula, find the sum of these 20 terms. Excuse me, if it will give us 480, then we would have, proven. So say, okay, we have S 20 terms, the sum of the 20 terms, if it gives us 80, then we are 480, then we are right. So say here 20 divided by 2, open brackets, then 2 times, then 5, then plus, open brackets, then n, which is 20 minus 1, which then times 2 as d here. Then we'll say S 20 is equal to 20 divided by 2, 10. Then here we'll say 2 times 5, 10. Then plus, then we'll say 20 minus 1, which will be 19. 19 times 2, 38. Then we'll say, okay, S20 is equal to, then when we add this plus this, which will be 48, then plus times 10, which will be 480. So hence we have proven this, because we have found that the sum of the 20 terms is actually equal to 480. All right, so let's see what is next. So task, this is the task for you at home to do at home. So it says number 1, the first term of an arithmetic progression is 126, and the 30th term is 387. Then find the 30th. Find the sum of the 30 terms. Yes, find the sum of the 30 terms. That's what it is. That's how it is read here. Find S30, the sum of 30 terms. All right, so you have to read and understand this question. Then number 2, is a sum of 8 terms of an arithmetic is 116, and the sum of 9 terms is what? 117. Then A, they're saying write down the value of the term number 9, the 9th term. What will be the value of the 9th term? Then 2, calculate the values of A and D. You calculate the value of A and D. All right, so we have come to the end of this mathematics lesson. As for now, bye and see you in the next lesson.